Hi, welcome to the Olympiad geometry. Today we're going to learn a new theorem. It's called 9-point circle. Here's the theorem. In triangle ABC, feet of 3 altitudes, midpoints of 3 edges, midpoints of also center to 3 vertices are on a circle. And we also have 2 corollaries. But now let's just look at the theory itself. I'll draw the figure here. So first we have a triangle A, B, C, and we find the feet of 3 altitudes. This 1, this 2, this 3. So these 3 points, and also midpoints of 3 edges. So here, this point, and let's see, roughly say here. Let's call it R, S, T, right? R, S, T are midpoints, and also midpoints of also center to 3 vertices, right? Also center is here, we call it H, and mid center would be this point, and this point, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. We want to prove that these 8, 9 points are on a circle. So first we know that 3 points that are not on one line. 3 points are not collinear define a circle, right? So we can just think about, we find the circumcircle of the triangle DFE, right? That's pretty straightforward. We find that circle already, and we just need to prove RST, and also these midpoints are on the circumcircle of triangle FDE. So before we're doing that, we notice that we actually want to prove all these points are on the circumcircle of 3 altitude, of the feet of the 3 altitude, right? So we just do some little research on these feet of altitudes first, right? So we have D here, E here, and F here. So if I connect FD and DE, right, we already know this is H. We already know that EHDC is cyclic, right? Because this is 90 degrees, this is 90 degree. So EHDC is cyclic, and also FHDB is cyclic. So because EHDC, FHDB are cyclic, so we know that angle EDH, this angle, equals to angle ECH, right? This angle equals to this angle. And the angle ECH plus angle BAC, that's 90 degrees. So it equals to 90 degrees minus angle BAC. We also notice that angle FDH this one equals to angle FBH. This one, right? Because this is cyclic quadrilateral, so angle FDH equals to angle FBH. And angle FBH plus angle BAC equals to 90 degrees. So which means A equals to 90 degrees minus angle BAC. Right? Which means AD is angle bisector of angle FDE. Right? We just proved that angle FDH equals to angle FDH equals to angle EDH. Right? So similarly, we can just prove BE is angle bisector of angle DEF, and CF is an angle bisector of angle DFE, right? It's just similar as this one. And if we have a circumcircle of triangle ABC, let me just try my best to plot that circle here, right? This would be the circumcircle of triangle ABC. In the past, we just proved that if we extend AD and intersect the circumcircle of triangle ABC on the point H prime, we know that DH prime equals to DH, right? We proved this before in many videos, I believe. We will just use this here, otherwise it's just too long. Okay, so let's just consider about the points that we already figured out a circle that are defined by the FDE 3-point, right? That circle would be the circumcircle of triangle FDE, and we want to prove that the midpoint of BC is on this circle. Right, the midpoint BC is on this circle. Basically, we want to prove that, let's call it R, D, E, F. We want to prove R, D, E, F is cyclic. So we can directly connect FR, right? R is the center of BC. Notice that, let's connect FE. Just notice that R is the center of BC, and triangle FBC is a right triangle, which means that BR equals to RF equals to RC, right? So we know this angle, so let's just do this. Angle BRF, right? This angle BRF equals to 180 degree minus because FR equals to BR, so minus twice of angle ABC, right? So remember that if we want to prove RDEF is cyclic, we have several ways, right? Another way, so let's just do it one by one. So the first way is we can simply prove the angle BRF equals to angle FED, right? Equals to angle FED. And we know that angle BRF, because BR equals to RF, so angle BRF equals to 180 degree minus twice of angle ABC, right? So for this angle, because we want to prove that this one equals to this one, so we just need to prove, and we already proved that BE, look at here, BE is the angle bisector of angle AEC, right? Because this is 90 degree, this is 90 degree. And also BE is the angle bisector of angle FED, right? This one equals to this one. So we just need to prove that angle FEA equals to angle ABC. Then we directly prove this angle BRF equals to angle FED, right? So let's try this. The angle AEF equals to, see here, angle AEF equals to angle AHF, right? Which equals to angle DHC equals to angle DEC. Right, so this one equals to this one equals to this one and equals to this one. Notice that this one, the angle DHC or the angle FHA or AHF, because BDHF is cyclic, so angle AHF equals to angle ABC, right? Because FHDB is cyclic, so angle FHA equals to angle FBC, so equals to angle ABC, right? So angle FED equals to 180 degree minus angle AEF minus angle DEC, right? And AEF equals to angle ABC, DEC equals to angle ABC, so it equals to 180 degree minus twice of angle ABC, which means angle BRF equals to angle FED. Right, that's very clear. Which means FEDR is cyclic. Right, based on this, because R is the center of BC, and we can use the same way just to prove that ST, which has the center of edge AB and the center of edge AC, are also on this circle, right? They also cyclic with FDE, right? So, which means SRT are on circumcircle of triangle FDE, right? Now the next point would be the center of BH. Right, we want to prove that the center of BH is also on this circle. So let's do it on this one here. Let's draw the FDE first. And then we draw it here. So notice that this point, let's call it M. M is midpoint of BH, right? M is a midpoint of BH, which means that because triangle BFH is a right triangle and M is a midpoint on BH, so BM equals to MF equals to MH, right? That make angle FMH equals to angle FMH equals to twice of angle ABE. Right? And from here, we just prove that AD is angle bisector of angle FDE, right? And we know that because FHDB is cyclic, so angle FDH equals to angle ABE, right? We already know that angle FDH equals to angle ABE, which means twice of angle FDH equals to angle FDE equals to twice of angle ABE equals to angle FMH, right? Twice of ABE equals to angle FMH. So FDE equals to angle FMH, right? That's FME, which means FMDE is cyclic, right? And from here, we just prove that the 3 feet of the altitudes, the midpoint on each edge, and also the midpoint from the author center to vertices are on the same circle, right? These 9 points are on the same circle. Okay, let's see the corollary. Corollary 1. The first one is saying that the center of 9-point circle is a midpoint from author center to circumcircle, to the circumcenter actually. The center of circumcircle. The radius of 9-point circle is half of the circumradius. Okay, so where is the center of the circumcircle? That's the intersection point. Let's draw it. Try to draw it accurately. Here, right? And we just want to prove that the midpoint from O to H would be the center of the 9-point circle. This would be easier if we draw the figure. So, yeah, this would be much easier if we draw it in another form. Okay, let's draw it here. A, B, C, and we have D, E, right? And the midpoint is here, midpoint is here. So this is O, and this is R, S. Right, and we know this is midpoint, call it T. So if we connect OS, OT, and OR, we know that OR is perpendicular with BC, OS is perpendicular with AB, of course CF is perpendicular with AB, and OT is perpendicular with AC, right? Basically, we just find that let's say this OS is in parallel with HF, and OR is in parallel with AD, and OT is in parallel with HE or BE, right? So think about this. Because R and D are on the are on this circle, right? So if we draw this one here, let's say this is R and D, right? Because R and D are on this circle, so we know that the center of this circle would be, if we draw from the midpoint of RD and we draw a perpendicular line from the midpoint to the RD, we know that the center of this circle must be on this line, right? Which means if we have O here, we have H here, which means the center of the 9-point circle must be on the line, must be on this line. Right, that's very clear. And also similarly, that the center of the 9-point circle would be on this line, right? So this would be a intersection point. And we want to prove that we want to prove that this point is also the midpoint of OH, right? We first of all we find this point. That point must be the center of the 9-point circle, and we just want to prove that this point is also on OH, right? It's also the midpoint of the OH. So think about that. Think about it like this way. First we have A, B, C, and H is D is here. E and H is here. So we have O is here, and another one R is here, right? So if I connect the OH, RD, so the perpendicular line from the midpoint of RD can intersect OH on one point, right? Let's call this point as V1, okay? Let's call this point as V1. And we can also find another point that from the midpoint of SF, right? Do a perpendicular line that intersects OH on another point. Let's call that point as V2. Let's assume V1 is not V2, right? V1 is not V2. So what's the property of V1? V1 has this property. It's on the line OH, right? On the line OH, and it has a distance that V1R equals to V1D. Right? That means V1 must be, because these three lines are in parallel, so V1 must be the midpoint of OH, right? V1 is midpoint of OH. And we also know that SF, the midpoint of SF, has an intersection point with OH, where that V2R equals to V2S. Yeah, sorry, not this one. Should be V2S equals to V2F. Right? That makes the V2 to be the midpoint of OH. Right? So V1 is the midpoint of OH, V2 is the midpoint of OH. That means V1 and V2 are overlapping, which means V1 and V2 is a point that this perpendicular line intersects with this perpendicular line, which is the center of 9-point circle, right? So we just prove that. And for the next question, that we want to prove the radius of 9-point circle is half of the circumradius. So because O is let's draw it here. Because V is midpoint of OH, right? And we want to prove that the radius of this circle, which is whatever VS or VF or VR, right? That's half of the circumcircle of ABC, which has a radius of OB or OA or OC. So the easiest way of this problem is actually, let me redraw this. So another point would be here. Oh, this is H. Right. So that's what we got basically from triangle FDE to find the circumcircle. But we can still remember that the three midpoint of the triangle ABC, three midpoint on the each edge of triangle ABC. That's the first way we got the circumcircle. But if we look at the three midpoint, right? That's RST here. That's a midpoint. And for this RST, because RST are midpoints, we know that SR is in parallel with AC and SR equals to half of AC. Also, TR is in parallel with AB and TR equals to half of AB, right? ST is in parallel with BC and ST is half of BC, right? So we know that triangle STR is similar to triangle ABC, and the ratio of that similarity would be half, right? Which means the circumcircle radius of the triangle STR would be half of the circumcircle radius of the triangle ABC, right? And that radius is a 9-point circle radius. So just prove the corollary 1. And for corollary 2, in triangle ABC, circumcircle O, circumcenter O, centroid G, 9-point center V, author center H are collinear, and there is a ratio, right? So let's first prove that these points are collinear. We already proved that circumcenter O and author center H and 9-point circle V are collinear, right? V is the midpoint of from O to H. We just need to prove that centroid G is also collinear with OHV, right? So let's just prove this first. Consider that we have a triangle here, right? The center of this circumcircle is O, right? That's a midpoint S R. S T, right? This is D, right? This would be H. So let's say this is H. We just need to prove that M G is on OH, right? G is on OH. So for the centroid, I think I'm not sure if I talked this before, but I believe it's very easy to prove. So let's find it. R S T, right? That's a centroid. Let's call it G. So AG to AR equals to 2, right? I'm not sure I proved this before, but it's very easy to prove because we can simply use the meaningless theorem in triangle ABR and the intersection line SGC, right? So that AS to SB times BC to RC times RG to GA equals to 1. AS equals to SB, so this is cancelled. BC to RC, that's 2, times RG to GA equals to 1, which means GA to RG equals to 2, right? So GA to RG equals to 2. Similarly, BG to GT equals to 2. CG to GS equals to 2, right? So now we want to prove that M is on OH. What we can do here is that we can connect BO, right? We connect BO to here. Intersect the circumcircle on another point, let's call it N. And we can connect NC, right? We know that BN is the diameter of the circumcircle, so angle BCN is 90 degrees, right? Which means NC is in parallel with AD. Right? So if we want to prove that the centroid is on OH, we can just connect OH, connect AR, and we just need to prove that the intersection point has a ratio that A to this, let's call this intersection point as M. We can just prove the ratio AM to MR equals to 2, right? Similarly to equivalent to AG to GR equals to 2, which means that M is G, right? That's the idea. So we want to find the ratio of AM to MR. But it's difficult to find the M here, right? So let's just think about R. R is the center point of the midpoint of the BC, edge BC. So once we do this BO N, we extend BO to N. O is a midpoint of Bn, right? So OR is half of NC, right? OR equals to half of NC. That is clear, right? OR is half of NC. So notice that the triangle OMR is similar to triangle AMH, right? This point is H. So I guess this is not very good. So this is direction connection. So here and here was H, right? This BT is perpendicular with AC, so this point is H. AH is in parallel with OR, and we connected OH. So it's very easy to prove that triangle ORM is similar to triangle AMH, right? ORM is similar to triangle HAM. Right? And because we want to prove that AM to MR equals to 2, right? In that case, M would be the G, the centroid. So we want to prove AM to MR equals to 2. But it's not an easy thing to directly prove that, right? So we just transfer it. AM to MR equals to 2. We don't know. But we know that OR, so because they are similar, so it's equivalent to AH to OR equals to 2, right? And we still don't know. We want to prove that. But we already know that NC is twice of OR, right? NC is twice of OR. Basically, we just need to prove NC equals to AH, right? NC equals to AH. That's the thing we want to prove. Let me draw it here. I think this thing, like NC equals to OH, we actually proved it before, but let's just do it again here. A, B, C. Right, this is H. This is N. We want to prove that NC equals to AH. This figure is not, I didn't draw it very good, but please bear with me. So AH equals to NC, that's what we want to prove, right? And we know that if, let's say, if NC equals to AH, and because AH already in parallel with NC, that just makes the AHCN a parallelogram, right? So basically, if we can prove AHCN is a parallelogram, that means we proved AH equals to NC. So how can we prove it is a parallelogram? We do this way. So let me draw it here. Right. we already know that AH is in parallel with NC. So if we can prove AN is in parallel with HC, we just prove it. Right? AN in parallel with HC. So if AN in parallel with HC, then this angle equals to this angle. Right? We just want to prove these two angles are equal. So this angle, the angle CAN, is reference to arc NC, right? Reference to arc NC. So the angle CAN equals to angle CBN. Right? It equals to angle CBN. Did I draw it wrong? Let me see it here. Yeah, that's fine. So angle CAN equals to angle CBN. Right? And we want to prove that this angle equals to this angle, right? The angle HCA equals to angle HDE, right? Angle HCA equals to angle HDE. That's what we just proved. And because this angle plus this is 90 degrees, so we know that this angle also equals to angle HBA, right? So angle HBA here. Angle HBA equals to this one. And we know that angle HBA plus angle BAC equals to 90 degrees. And for the angle CBN plus angle BNC equals to 90 degrees, right? Because NC is perpendicular with BC. So we already know that angle we already know that angle BNC equals to BNC because A and CB are cyclic, right? So angle BNC equals to angle BAC. So from here we know that angle HBA equals to angle CBN, right? Angle HBA equals to angle CBN because angle HBA angle HBA equals to angle CBN and angle HBA equals to angle HCA, right? This one equals to angle HCA. And also angle CBN equals to angle CAN. So we know that